Hello. Okay, let's look at this question here. Right. Okay, pause the video, read the question, and try it if you already learned it. Alright. So this is a question involving normal approximation. Right. Normal distribution as an approximation to the binomial distribution. Alright. If you read this question carefully, you will know that why we need to using normal approximation. Very simple. Because why? The probability of a guided missile, right? The probability of a guided missile hitting, alright? The probability of a guided missile, you know that for war is hitting its target is 0.64. Hitting the target means that if the missile is hitting the target means success, right? Success. So it means that it's either hitting the target or not hitting the target, right? So there is two possible. One is success, one is failure, right? And find the probability that out of 500 shot, there is a test of 500 shot, means the sample of 500. So this is a binomial distribution, right? It's a binomial distribution because each of the shot is independent, right? The missile hitting the target, the first shot and the second shot, the third shot, they are all independent. Okay. So that's why we know that this is a binomial distribution with number of try. Wow, the sample very big. That's the problem here. The sample is very big. It's more than 50. Alright, and 0.64 is the probability. Alright, it's okay. Usually during the lesson of when I'm talking about binomial distribution, right, the sample is not that big, right? The sample must be 50 or less, right? Less than 50. So we can using the statistical table, right? Statistical table, table 1, table 1 in your okay, in your matriculation program statistical table. Alright, using table 1. But now there's the problem here. What's the problem? Can you notice that the problem is in our table, the biggest value for n here, n is 500. Oh, if you're doing a lot of questions, you should know, right? You should know that the biggest n here will be 50, right? The biggest n here will be 50. So if we insist that want to using statistical table, right? If we insist want to use statistical table, so we need to do something. We need to do something. So here 50. Okay, 0.65 is not even at here at all, right? Not even at all. So what happened? What happened if you still want to using to using statistical table? We can doing approximation. We can doing approximation. So how is it? The condition is to doing approximation. Binomial distribution can approximate to another discrete distribution, but that one we never learn here, right? But now I'm going to using normal approximation, right? Normal approximation, because why? There is a condition. If you want to transform this into a normal distribution, normal distribution, it must have a mean, right? It must have mean, and it must have variance, right? So now this is the most important thing that I tell you, okay? Is I transform from a discrete random variable. Binomial is a discrete distribution, and I want to using the normal distribution as an approximation to binomial distribution. Means that is I convert from the discrete random variable into a continuous random variable. Discrete, okay, very easy lah. I just tell you, discrete to continuous. We need to do continuity correction. Right here first. Okay. Later on, we know what to do. Continuity correction. So now, before that, you want to transform to this distribution, you have to find the mean, right? The mean for the formula for binomial is NP, and the variance is NPQ. NP multiplied with Q. What is NP? You just take 500 multiply with 0.64, right? 0.64. NPQ is 500 multiply with 0.64 and multiply with 1 minus 0.64 is 0.36, right? 0.36. So after you using calculator, you find the value to be 320. 320 is a very big number. The mean is very big number. Okay, and this one is 115.2. Alright. So but you can it's the best if you do approximation. The best means the condition, right? The condition, okay, I write here the condition for binomial distribution to using the normal distribution to solve the problem. We have a condition which is the value of NP, the mean, alright? The value of n multiplied with the p must be greater than 5. Alright? Must be greater than 5. It's not only greater than 5, it's also a minimum 5. Okay, NP greater or equal 5. Alright, as long as the condition is greater than or equals to 5, start from 5, you can using approximation. It will be quite accurate. Alright, so okay, this is the one that you should know. Alright, you should know. Okay, there are different type of books have different version of condition. Alright, for matriculation we talk about this. So NP is more or greater or equal 5, right? So and the value of P is the best lah. It's the best in between 0.1 to 0.9. Alright, in between. Better it's in between this value. Alright, better. So okay, now okay, why I can doing this? Why I explain this? Okay, please listen. Alright. So you see, NP more than 5. You see, NP you darab. You getting 320. 320 is a lot bigger than 5, right? So the condition 1 is pass. Right? Is the P between 0.1 and 0.9? We see, is the P between 0.1? Yes, the P. This is the value of P. Yeah, 0.64. Right? 0.64 is between 0.1 and 0.9. Right? It's between 0.9 and 0.1. Yes, it's already fit the condition. Right? We can doing approximation already. Alright, so okay, now we know that the mean and the variance, right? The mean we know to be the value of 320, and the variance, right? The variance is 115.2. Okay, now we can start answering the question. Alright, okay, just now I have shown you why I'm supposed to doing approximation, right? I have write the condition here, right? Pay attention. But if you transform from a discrete distribution, binomial or Poisson, into a continuous distribution, normal distribution is a continuous distribution, we need to do continuous correction, alright? Always remind, right there and remind yourself, okay? So look at question A. Find the probability that out of the 500 shot, right? 500 shot, 500 try, the target will be hit at least 350 times. At least 350 times. Alright, so now you remember, always remember 350 times at least. This is a discrete. X suppose is a discrete random variable. Okay, it's a discrete random variable. But now you already transform. You sudah ubah daripada binomial menjadi normal distribution. Right, it's a discrete to continuous. Remember, the remember here is remember this. The CC must do continuity correction for this lesson here. So the continuity correction, definitely you must watch the video for continuity correction before. Okay, this one. Okay, draw a box, right? 350. So you have 350.5 plus 0.5. Here you minus 0.5. You have 349.5. Right. So at least means that greater or equal 350, right? So there is an equal here, so I draw the box, okay, shade the box, right? And greater means box and the right, okay, to the right. So now where I start to shade the region, right? I start to shade from 349.5. So the CC here, I have to do the continuity correction. So the probability of X at least I taking. Okay, now the value is start from 349.5 and above, right? And above. Why I shade this? Again, I remind you, got equal, right? Why is on the right? Because greater, alright? 349.5. So it's 349.5. Saya sudah buat adjustment, sudah adjust. Because I transform to normal distribution. You're not always doing this, not always doing this, you're only doing this when you do approximation. Alright, okay, now I can start to convert this become normal, right? I don't using discrete, now I'm using normal distribution, right? So, okay, so I convert. Do you still remember that if I want to using, I have to standardize the score, right? Standardize the score by using normal distribution. So I'm taking 349.5 minus away the mean, right? Minus away the mean is 320 divided by the standard deviation, right? Standard, this is variance, right? Variance, sigma square. So if you want to find the standard deviation, so you just square root of 115.2, right? 115.2. So, okay, you just write it, PZ from calculator. What is the value? So let's see what's the value. The value will be 2.75. All right, 2.75 from statistical table, right? This one you have to using the table 4, right? Means that you cannot using the binomial. 500 too big already. 500 is too big already. All right. You cannot using table 1, right? You cannot using table 1. The maximum value here will be 50, right? So that's why you need approximation so that you can using the normal distribution. Okay, you can using the normal distribution. Means now I want to using table 3, right? Table 3. So that's why if you want to from table 1, you want to use table 3, you have to do some CC. Okay, you have to do CC, continuity correction. So 2.75, right? 2.7. Where are you? 2.75. Okay, 2.75. So is 0.00298. 0.00298. This is the probability, right? Probability for part A. Okay, let's look at part B. Alright, okay, let's look at part B of the question. Probability that not more than 340 times, right? The probability that out of the 500 of this guided missile, the target will be hit at not more than 340 times. Not more than means less or equal, right? Not more than 340 times. Not more than, okay? If I said not more than, if I said not more than 5, for example, if I said not more than 5, tidak boleh lebih daripada 5. Kosong boleh kan? 1 boleh kan? 2 boleh kan? 3 boleh kan? 4 boleh kan? 5 pun boleh, asalkan tak lebih 6. 6, 7, 8 saya tak mau. Okay nak? Means that this is what's the meaning of this? It's the same as at most 5, right? They are almost the same meaning. At most 5 is the same as not more than 5, alright? Okay, so this is at most 340 times, or we said that not more than 340 times. So very simple. If you forgot to do continuity correction, is wrong, okay? You should not do that, because why? You want to using the normal distribution, right? So you have to do a CC, okay? Continuity correction. So, okay, what is the correction here? I don't know what is the value here, I don't know. So, I draw a box lah, okay? Once you already become an expert, for continuity correction, you don't need the box. The box is for me to guide you, right? It's for me to guide you. So, 340. So, here will be 340.5. Here will be 339.5, right? You tambah 0.5, ini tolak 0.5, right? So, ada equal tak? Ada equal letak color lah, okay? Lorekkan, okay? Lorekkan. Less than maksudnya mana? Less than maksudnya di sebelah kiri, okay? Not kiri. Here, right? Kiri. So, start from where? From to the left, go to here is less than, right? From here means that less than from negative infinity up to 340.5. So here will be 340.5, right? This is the continuity correction, okay? Must do, very important, okay? I'm not simply telling you, okay? It's very important because you're doing approximation, alright? The sample too big, so then you convert become Z less or equal. Standardize the score. You want to using normal distribution. So 340.5 minus with the mean, right? Using that formula, 320 divided by the square root of 115.2, right? Okay, let's see what's the value. I think this one should be no problem. This one should be no problem. All right. This question, I just introduced another concept where we're doing transformation of the distribution, right, from discrete to continuous, and we're doing CC. All right. So now less or equal. Okay, calculator. Let's using this. I think you are getting the value of 1.91, right? 1.91. So 1.91. So 1.91. Okay, you already become an expert for this, right? You should not be a problem here now. Okay. So you know that standard score, right? Z 1.91. 1.91 is here. It's on the right. Less than means here, right? Less than means here. Okay, less than 1.91. So it's the probability must be greater than 0.5 lah, right? So it's everything minus away a small section here, right? 1.91. All right. So this is in your mind, right? This is for me to guide you, okay? For guide you. This is not a working, you know. This is for me to guide you. I want to teach you, right? So I have to guide you. So this one is everything, means that less than 1.91 is this one, right? It's the same as everything 1, right? So I write here is equals to 1 minus with PZ greater or equal 1.91. Okay, sir, do I need to put equal or without the equal? Can I just not putting the equal? Yes, you can, right? After continuity correction, you want to put equal, no equal, doesn't matter. But here you must have here, because why? This is a discrete, right? It's a discrete. But after you doing continuity correction, the equal or no equal is become insignificant, okay, not so important. Okay, so now is PZ greater or equal. You don't want to write equal, also never mind. 1.91, right? More than 1.91. So from statistical table, find the value of 1.91, right? 1.91. So 1.91, all right, 1.91. Okay, 0.0281, right? 0.0281. 0.0281. So equal, when you minus, you're getting 0.9719 as a probability that not more than 340 times the shot hits the target. Okay, let's move on to the next one. Okay, hope you understand. Right, okay, the last part of this question, the shot hits the target with 310 times to 340 times. All right, so the meanings of here will be probability of 310 to means include 310 up to 340 times. All right, 310 and 340. So this is the meaning of 2, right? 1 to 5 means include 1 and 5, right? So okay, so because you already decide to using normal approximation, okay, so you must do continuity correction, right? You must doing continuity correction. So how to doing continuity correction? This is 2 values, so you imagine in your mind, right? So now you should be better already. 310, here will be 340, right? So here will be 340.5, here will be 339.5, right? Here is 310.5, this is 309.5, right? If you're taking this minus with 0.5, right? You're getting 309.5, right? So now how to doing this? So we know that we are doing the continuity correction, right? If the equal here is very important here, because initially pada mula here, this is discrete random variable, right? So now, okay, you can see that this is equal. Equal means that you go and shade this one, and then equal, then you go and shade this box here, right? Shaded, right? Shaded. If no equal, then don't need to shade lah, right? So in between means from here, right? In between. So from where to where you color? You start from where? 309.5, right? So the CC will be probability 309.5, right? Start from 30.5 up to the shaded region up to 340.5, right? 340.5, right? 340.5. So student were asking me, sir, after I doing continuity correction, after I doing continuity correction, do I need to put an equal here? Doesn't matter. Doesn't matter. You don't want to put equal, you want to put one equal, suka hati, okay? But for me, I just copy back lah, okay? So equal, then put equal lah, okay? No equal doesn't matter, but here you must, okay? It's a discrete random variable. It's a discrete random variable. Now you transform, okay? So now, okay, finding the probability. So you have to convert this into score Z, right? Score Z. So you have to show your working 309.5 minus with 320, right? Divided by the square root of 115.2. Same thing also for this, you're taking the x value minus with the mean divided by the square root of 115.2, right? So after you convert, you can see that the score Z is in between these two values, okay? Which from calculator, I know that the value will be 0.98, right? 0.98 for this is 0.98, and for this will be 1.91. Sorry, this is negative, negative 0.98. So how to evaluate this one? You already learned during when I explained about normal distribution, right? So okay, this is the region. Okay, this is the region. So 0 here, always 0 here, right? So here is negative 0.98, right? Negative 0.98, and this is 1.91, right? 1.91. So positive, negative, so it's become in between here, right? In between here. So this is the same as you taking everything. Everything means the total area under the normal distribution is 1, right? 1. Minus away, little bit on the left here. The left here, right? The left is negative 0.98. And minus away little bit on the right here, which is 1.91, right? 1.91. Okay. So you see that this is the lower tail, this is the upper tail. Our matriculation statistical table is using the upper tail, so don't disturb this one, don't disturb this one, right? So this one you have to reflect. You have to reflect. Is everything minus away? It's become 0.98 here. 0.98, right? 0.98. I change it from the left tail to the right tail, right? So minus with 1.91, right? So okay, this is in my mind, right? In my mind, so I know that it's 1 minus, because now this one is 1 minus with PZ, PZ greater than 0.98 minus with PZ greater than 1.91, right? Greater than 1.91. So okay, I'm not going to show how to use it. Findings from statistical table, you should be an expert already. So I'm just telling the value from statistical table 0.98, from table 3 normal distribution is 0.1635. Okay, and this one will be 0.0281, right? Okay, after calculate, you are getting the value of 0, the probability is 0.8084. So that's the probability required by the question. Okay, this is the way how we're solving this question. Why we never using binomial distribution? Very simple. One is the sample is very large, all right? The sample very large. So we try to think that we using another distribution to helping us in solving this problem. For example, this case I using I transform it from the discrete into continuous, or I said that the normal approximation, I using normal distribution as an approximation for the binomial distribution, but there is a condition, right? Okay, you try to play back the video again. There is I stating a condition there. All right, that's all for this video.